Alright guys, today we are going to review your practice test, and since I can't be here, I'm going to do it on the video. If you have any questions or you want the video paused, just ask to pause it, and then you guys can go over those questions together. Number 1, tell whether the ordered pair is a solution to the given system. We're given the ordered pair 0, negative 5, and the system y equals negative 6x plus 5 and x minus y equals 5. So we need to check and see if that's true. Your first number in your set of ordered pairs is always your x. Your second number is always your y. So if I start with my first equation and I plug those values in, I get negative 5 equals negative 6 times 0 plus 5. Negative 6 times 0 is 0. So I end up with negative 5 equals 0 plus 5. And 0 plus 5 is 5. So I get negative 5 equals 5. Is that true? No, obviously not true. So then if that's not true, then we say that no, that ordered pair does not satisfy the given system. If I look at number 2, I'm given the ordered pair 1 and 3/4 and 7 and 1/4. And then given the system x plus y equals 9, 2y equals 6x plus 4. So I know that my first value is always my x, second value is always my y. That was my first equation. X, which is 1 and 3/4, over 1.75. I'm going to rewrite these as decimals. Plus my y, which is 7 and 1/4, which is the same thing as 7.25, equals 9. So if I solve that, then 1.75 plus 7.25 is 9. So I end up with 9 equals 9. Okay, there's my first equation. Second equation that I have to check is 2y equals 6x plus 4. So we just figured out my y is 7.25. So 2 times 7.25 equals 6 times 1.75 plus 4. Well, 2 times 7.25 is 14.5. 6 times 1.75 is 10.5. So I get 14.5 equals 10.5 plus 4. 10.5 plus 4 is 14.5. So I get 14.5 equals 14.5, which is true. And since both of them are true, we say this is a yes. That ordered pair does satisfy that system. Okay, next problem on your test says solve each system by graphing, classify the system, check your solution. I don't need you to classify it or check your solution, I just need you to solve it by graphing. So if I look at number 3, y equals 3x plus 2 and y equals negative 2x minus 3. I need to make 2 tables of values to solve for my system. If I use the x's 1, 2, and 3 for both of them, I plug in 1, 3 times 1 is 3, 3 plus 2 is 5. I plug in 2, 3 times 2 is 6, 6 plus 2 is 8. I plug in 3, 3 times 3 is 9, 9 plus 2 is 11. Okay, then for my second equation, if I plug in 1, negative 2 times 1 is negative 2. Negative 2 minus 3 is negative 5. I plug in 2, negative 2 times 2 is negative 4. Negative 4 minus 3 is negative 7. If I plug in 3, negative 2 times 3 is negative 6. Negative 6 minus 3 is negative 9. So if I go ahead and graph those, if I graph my first equation, 1, 5, that's over 1, 5 on my x and y axis, over 2 up 8, and over 3 up 11. And then I connect those points with a straight line. If I graph my second equation, 1, negative 5 is over 1, down 5. 2, negative 7 is over 2, down 7. 3, negative 9 is over 3, down 9. Then I need to connect those points with a straight line. It's close enough, and we see where they cross. And where they cross is going to be our solution. So I'm going to go back 1, down 1 to get where they cross. So going back 1 means -1. Going down 1 means -1. So my solution in my ordered pair is -1, -1. Right, I'm going to skip number 4 for now and go back to it later if we have time. Number 5. Solve each system by substitution, classify the system, and check your solution. So we're solving by substitution. We're not worried about classifying or checking the solution. We're worrying about solving by substitution. Okay, and substitution is where you take what y equals. So y equals 2x plus 12, and you plug it in for y. If I do that, then I end up with 2x plus 12 equals x plus 3. This is like a 1x. So to move my 1x, I'm going to subtract it, because the opposite of a positive is a negative. The 1x's then cancel. All I'm left with on the right is a 3. 2x minus 1x gives me 1x, and I still have my plus 12. Next up is I need to get rid of this plus 12. I get rid of addition by using subtraction, so I'm going to subtract 12 from each side. Then the 12's cancel, and I'm left with just 1x, and 3x minus 12 gives me -9. The last step is that I have to get my x by itself, so I'm going to divide each side by 1. If I do that, then -9 divided by 1 is -9, so x is -9. We are not done, however, because we have to also find our y value. And so we take this -9 and we plug it back in for x in our second equation. So if I do that, y equals 2 times -9 plus 12. Well, 2 times -9 is -18. -18 plus 12 is -6. So I get x is -9, y is -6. If I look at number 6, I'm given the system x plus y equals -1, y equals -2x plus 3. We are solving this by substitution, which tells me I'm taking what y equals and then plugging it in for y in my first equation. If I do that, then I end up with x plus -2x plus 3 equals -1. First step is I have to combine my like terms. This is like a 1x, so this is like 1 plus -2. 1 plus -2 is -1x. I still have my plus 3, and I still have equals -1. To get rid of a plus 3, I subtract 3 from both sides. So I get -1x equals -4. And then you divide by -1 to get x equals +4. Okay, we should all be really good at those by now. Now that we know what our x equals, we can find out our y by plugging in 4 for my x in my second equation. So if I do that, then I end up with y equals -2 times 4 plus 3. Well, -2 times 4 is -8. -8 plus 3 is -5. So x equals 4 and y equals -5. Alright, if you flip to number 7. Number 7, we are solving each system by elimination. So we're given the system 4x plus y equals -1 and 2x minus y equals -5. So the first thing I have to do is see if I have anything that's the same. These are both 1y's, so I know that those are the same. Okay, so that's what I'm going to eliminate. You eliminate the things that are the same. Then we look at the signs. Top one is positive, bottom one is negative. When they are opposite signs, you add your equations. So we're going to add our two equations together. So if I do that, 4 plus 2 is 6x. My y's cancel. And 1 plus negative 1 plus negative 5 is negative 6. Then to finish solving that for x, I divide by 6 on both sides, so x equals negative 1. And now I need to plug that back into my equation to solve for y. So we'll plug that back into my top equation to solve for y. So 4 times negative 1 plus 1y equals negative 1. 4 times negative 1 is negative 4. So negative 4 plus 1y equals negative 1. Okay, and then to get rid of that negative 4, I add 4 to both sides. So 1y equals 3. Divide by 1, y equals 3. If I look at number 8, 3x minus 2y equals negative 6. 1/3 x plus 3y equals 9. So I kind of have a problem because none of my x's and none of my y's are the same, so I need to make them the same. So if I want to make my y's be the same, then I need to multiply the bottom by 2 and the top equation by 3, multiplied by the opposite. So I got 2 goes to the bottom, 3 goes to the top. Okay, so then 3 times 3x gives me 9x. 3 times negative 2 gives me negative 6y. And 3 times negative 6 gives me negative 18. 1/3 times 2 gives me 2/3, which is 0.67x. 2 times 3 gives me 6y. And 2 times 9 gives me 18. Now that I have my y's to be the same, I look at the signs. Top one is negative, bottom one is positive. Opposite signs tells you to add. So we're going to add these two equations together. 9 plus 0.67 is 9.67x. My y's cancel, and negative 18 plus 18 is 0. I then divide by 9.67 to both sides. 0 divided by 9.67 is still 0. So x is 0. Then I can plug that either into my top equation or bottom equation to solve for y. I'm going to plug it into my top equation. So if I plug that into my top equation, I get 9 times 0 minus 6y equals negative 18. Well, 9 times 0 is 0, so I end up with negative 6y equals negative 18. Divide by negative 6. Y equals positive 3. Alright, 9 and 10 are you get to solve those by your own choice. So we've done graphing, we've done substitution, and now we've done elimination. So I'm skipping 9 and 10 because those are going to depend on which method you think is the easiest. So if I go to number 11, this is where we get to our inequalities, which is what we worked on the last couple of days. So number 11, I'm given the order pair 0, negative 3, and the inequality y is less than 2x minus 3, and I need to decide if that is true. So I let x be 0 and y be negative 3. if I plug those in, then I get negative 3 is less than 2 times 0 minus 3. So then I get negative 3 is less than 2 times 0 is 0. So I get 0 minus 3. And 0 minus 3 is negative 3. So I get negative 3 is less than negative 3. Is that true? No, right? Negative 3 is equal to negative 3. Negative 3 is not less than negative 3. So then we put no, that is not true. If I look at number 12, I'm given the ordered pair 2, negative 1, and the inequality y is greater than or equal to x minus 3. Okay, so if I let x be 2 and y be negative 1, and I plug those in, I get negative 1 is greater than or equal to 2 minus 3. So negative 1 is greater than or equal to 2 minus 3 is negative 1. So I get negative 1 is greater than or equal to negative 1. Is that true? Yes, that's true, right? Because negative 1 is equal to negative 1. So we would say yes, and we would be done. Alright, on number 13, we're given inequality y is less than negative 2x plus 5, and we're told to graph it. So we're going to make a table of values. So if I plug in 1 for my x, negative 2 times 1 is negative 2. Negative 2 plus 5 is 3. I plug in 2. Negative 2 times 2 is negative 4. Negative 4 plus 5 is 1. And if I plug in 3, negative 2 times 3 is negative 6. Negative 6 plus 5 is negative 1. So if I graph those, I go over 1, up 3 to get my first point, over 2, up 1 to get my second point, and over 3, down 1 to get my third point. Before I connect those points, I have to decide what type of line I have. So I look at my inequality. Is that going to be a solid line or dashed line? Dashed line, right? Because it does not include the line underneath. So if I dash my line, then the last thing I have to look at is whether or not I'm going to shade above or below. Since that is a less than symbol, we shade below our line because we shade values that are less than that graph. So your graph should look something like that. If I look at number 14, actually I'm going to skip 14, 15, go on 16. If I look at number 16, graph each system of linear inequalities given ordered pair that is a solution and check to make sure that it is a solution. So I'm given y is greater than or equal to x plus 4, and y is greater than 6x minus 3. So I need to make two tables of values to graph both of those equations. So if I use x's of 1, 2, and 3, if I plug in 1 in my first equation, 1 plus 4 is 5, 2 plus 4 is 6, and 3 plus 4 is 7. So for my first graph, I'm going to go over 1, up 5, over 2, up 6, over 3, up 7. I then need to look at my inequality to decide which type of line I'm going to have. Since it is greater than or equal to, because it includes that line underneath, it's going to be a solid line. Okay, and then since it is a greater than graph, we are going to shade above. Okay, so I look at my second graph and make the same table of values. I plug in 1 for x. 6 times 1 is 6. 6 minus 3 is 3. If I plug in 2 for x, 6 times 2 is 12. 12 minus 3 is 9. If I plug in 3 for 6, 6 times 3 is 18. 18 minus 3 is 15. So I'm going to go over 1, up 3, over 2, up 9, and over 3, up 15 will be off my graph. Then if I look at my inequalities, is it a solid line or dashed line? Dashed line because it does not include the line underneath. So I draw a dashed line going down, and I look at whether or not I shade above or below. Because it is a greater than symbol, we shade above our graph, and our solution set is area where both colors are mixed. Alright, so I'm going to stop it there. You guys need to study for your test that you are taking tomorrow.